Awesome. The one thing I hate about public speaking is I can never see you once I get up here, and I always forget that ahead of time. I'm like, I'm just going to, get a read of how asleep everybody is, and I get up here and realize I can't see you at all because of the lights. So I'm just going to stare out into the void here, and if you leave, I probably won't notice. I always ask for this time slot because I'm the last speaker between you and drinking. And I think it lowers expectations a lot. You guys can't possibly absorb any more information, and you really just want me to wind up so that we can all get a cocktail. So rather than trying to help you learn anything, I think my goal for today is to terrify you mostly, and then inspire you a little bit. Well, mostly terror, I guess. And this is a preamble slide. People were talking earlier when I was getting ready to come up here and speak, oh, I really hope the clicker actually works. Nobody told me where to point it, so. Okay, that's going to work eventually. Folks were saying, hey, we're scared of change. Change means bad. And nobody else had used this slide yet. This is a really popular slide in the Agile world, so I just figured if I use the slide, you can all take it home and you say, no, this is why more change faster is good. This is why continuous deployment and automation actually reduces risk for an organization. It's because it's not change that's dangerous, it's big change. It's changing all the things at once. Somebody up here earlier was saying, just change one variable at a time. I just wanted to reinforce that with a little visual. Lots and lots and lots and lots of deployments all the time is way less risky than the way we do it today. All right, I want to talk a bit about infrastructure as a code. Along with terrifying you and inspiring you, I'm also going to be hopefully equally offensive to every other speaker. I usually am offensive, but I try and spread that out, hate on everybody a little bit. And I get away with that not because of my current role, which actually I'm supposed to be kind of respectable now, which is a little weird. But my previous role, I was one of the co-founders of OpenStack. I don't know if any of you guys have heard of that. Also, I still can't figure out where to point this. OK, it's going to work. And while working on OpenStack, I had the opportunity to then work on building support for Cloud Foundry on top, and I got involved in the PaaS ecosystem as well. So I get away with talking about cloud a lot in a way that's probably unfair, considering I never went to college and stuff. But so I'm going to do that thing that cloud people always do, which is I'm going to start by defining cloud, even though you've all heard like a million definitions of cloud before. Where? Anywhere? Over. I pointed at you. OK, that works. Thank you. Most people, when they say cloud these days, they mean Amazon. And so they mean that it's outsourced and billed per unit of time, which is a totally legitimate definition of cloud. It's just not the one I use. So when I use the term cloud, I mean that it's programmable and that probably behind that API, it's automated. And I think that's more interesting if you're thinking about cloud as a spectrum of private cloud to public cloud with community clouds and managed private, hosted private combinations in the middle. All of those are programmable and automated. Not all of them are outsourced. Not all of them are billed in the same way. One of the themes today is about going fast, and so I wanted to tell a little bit of a story to start with. Before I worked on OpenStack, before I worked at NASA, I was a tech lead for the Netscape browser for a few years. And the program manager at Netscape was this guy, Bob Parsley, and he had this sign on his office door. And I just thought it was such a great summarization of like connecting back to the idea of why we build software is so that it will exist in the world. And that it's rare, it does happen, and I think he was perhaps a little optimistic, AOL, given how they're doing, maybe missed this point a bit, but it is rare for software to be so bad that it is better not to ship it than to go ahead and ship it. And this idea of speed, I think this is actually out of batteries. I think that's what's going on here. When we built Nova, which was a precursor to OpenStack, we shipped it 17 days after we started. And without that approach, actually, OpenStack wouldn't exist at all. Rackspace had gone one better. They had actually announced OpenStack before they wrote any of the code. But we sort of backfilled with that 17 days behind the announcement. So it worked out all right. And I think it's useful and illustrative in that sort of inspiring way to look at, what is now still the fastest growing open source project in history, one of the largest now, and say, okay, well, that came about because folks were willing to go very fast. And that theme of like going fast is important. I'm gonna keep hammering on in a minute. Now I want to set some context. At NASA, I did not take the job to go build infrastructure as a service. I actually don't really like infrastructure. I used to be an application developer, and way back in the day, I used to actually write software, and I liked doing it, and I thought I was pretty good at it, and I'm not very good at IT infrastructure. IT infrastructure is hard and unforgiving. Real physical devices fail in ways that are annoying. I remember the first time somebody told me that bits in hard drives could get flipped by cosmic rays. I was like, you are totally shitting me. It actually happens all the time, which is really annoying. It's one of those reasons hardware is really annoying. So the reason we built OpenStack is because I got hired to build a platform as a service, and I couldn't figure out how to do it without a cloud underneath, and we weren't allowed to use Amazon. So I said, we'll just whip up a quick clone of Amazon, and then we'll build on top of that. And I figured, 17 days in, this was mostly done, put a bow on top of it. 5 years later, I finally got out of the project. So that should be a lesson to you as well. Things that you start quickly will eventually go slowly, which is why those tools matter. Okay, so I really wanted to build Cloud Foundry. I did not get to build Cloud Foundry. A bunch of other people built it while I was working on OpenStack, but I eventually got to join it. How many of you have heard of this? Okay, good. That's handy. I think the number one reason I'm here talking to GE is because when we started this company, Pivotal, which is sort of the major corporate sponsor behind Cloud Foundry, GE bought almost 10% of Pivotal for $105 million. So you guys are the only customer of Cloud Foundry who's also a shareholder in the company that works on it. So you have an unfair advantage in terms of asking us for features. It is the world's leading open source platform as a service. It has an open source foundation now that was set up over the last year and actually announced and launched in January. All the usual suspects, IBM, HP, et cetera, are all members of that, as well as Pivotal, as well as GE. And it has some really cool characteristics, most of which I'm not going to talk about, because I think you're already down that path, frankly. And I think that's exciting. What I do want to talk about is some of the guts of Cloud Foundry and how the automation works and why it matters. Because I think the approach to what we did in there can be applied to a lot of these other problems in the data center, and I think it's an approach that doesn't look anything like the rest of the tools we talked about today. Now this is where I start to offend all of the other vendors. An overly simple view of the world inside Cloud Foundry is that you have applications, and in the modern cloud world, a cloud-native application is stateless, which means state is somebody else's problem. It doesn't write to disk. It doesn't own the databases. And it should be perfectly horizontally scalable. So if you want to respond to more requests, you make another copy of that app, and you run it next to the first app, and you load balance, and that should always work, right? So containers are really popular for doing this kind of deployment. You don't have to run apps in containers. You can run them in VMs. You can run them on dedicated hardware. But the cool kids are now all using containers for this. State doesn't go away. There's nothing magical that says, yeah, we decided to write an application with no state. Well, it probably has no value then. Eventually, you need state. And so what we've done is we've abstracted the hard problem of storing state. And we said those are data services. They're either a database or a queue or a NoSQL store or a document store, some kind of data service. And we're going to let all these stateless apps talk to those, because scaling those is an interesting and hard problem. We call diagonal scaling usually. And it requires a different set of tools. They're usually run in VMs. Sticking data services into containers, although, again, lots of people are doing it, doesn't make a ton of sense, because containers don't have good management of disk, frankly, yet. Maybe a couple years. So they have durable storage, and usually they're multi-tenant. You think about a database. Your Oracle database is a data service. MySQL running in a VM is a data service. A Redis cluster, or in fact, a Hadoop data lake, data service. Cloud Foundry deals with both applications and services. And by which I mean deals with, it actually orchestrates both the VMs and the containers. And we use the tools that we use for managing data services to run the tools that we use for managing containers. It's actually, Cloud Foundry has these two major components. On the services side, we call this tool Bosch. It's a separate open source project. You can go look at it. I'm going to insist that you all do that. In fact, I'm going to get them to lock the doors until you've all signed up for the mailing list. Bernie told me that I should give you guys some take-home, some like actions to do. Okay, well, this is your action to do. And then on the container side, that system is called runtime. Runtime totally, and I really, if you take one thing home from today, think about this, that applications and services are different problems. They have different architectural constraints, and they need different approaches to orchestration. So I'm going to take a little digression here and tell you some history. It's 2015, and 10 years ago, Puppet was invented. And in those intervening 10 years, we then had the launch of cloud with Amazon EC2, the Google Big Table paper, which led to the creation of Hadoop, Facebook, the App Store, Netflix doing video streaming, and eventually Amazon coming out of beta. So every major driver of what makes it hard to deliver business IT today, which people usually say is social, mobile, and global, came after the invention of the configuration management tools that we keep looking at and saying, those will be able to solve this problem. No, they won't. In this business context of your apps have got to be social, which means arbitrarily confusing things, but probably that the folks consuming your IT product, end users somewhere, whether they're inside your company or not, are 20 years younger than you, or 20 years younger than me. I have two daughters. Eldest one's turning 12. She is on her phone all the time. And their expectation of the world is you just download it as an app. The app should get updated every day. They know because they push the update button in the App Store. And it should be getting cooler every time you push that button. Consumerization of IT is first and foremost this bucket of expectations. The second driver there is that your executives, and if they're in the room, I'm going to offend them as well. This used to happen all the time at NASA. They're like, we need you to build us a cloud because everybody at NASA wants to go use Amazon because they think it's only 10 cents an hour. Like, well, if you pay for the data back and forth and you still have to have IT operations people, it's actually not cheaper than what we're doing. But we've never proven that because we weren't in the habit of proving how much stuff cost. So the expectation now is people look at consumer prices as, well, I can buy a terabyte at Fry's for 12 bucks. Why is your storage so expensive? This is the context in which we now operate IT. And global, which from a business standpoint is great. We can go sell to everyone in the world. More and more countries can afford to buy what we're selling. And their economies tend to collapse at different times. So in theory, that keeps our balance sheet level. The problem is we used to get downtime windows. I remember, I'm a grumpy old man. I'm only 37, but I started coding when I was 6. And so I remember writing software before we had networking. And it was easy. Because the expectation was there was a very limited set of I/O that you had to support. It was what was on that computer. The idea of then writing something that would talk to other computers, which I started doing in high school, all of a sudden very more complicated, kind of exciting initially, and then gradually more and more terrifying. The nature of globalization is we now get no downtime at all. And every time, the only website that I publicly use that has scheduled maintenance windows on a regular basis is irs.gov. And it makes me crazy. All I want to do is give them money. They won't take my money because they're down for maintenance. I think I would have paid them off already if they just kept the website up. Okay, that's the broader context. Let's look at sort of real world data here. You know, in the mainframe era, people's expectations on IT were pretty low. That was also, by the way, when we invented shadow IT. The term shadow IT, how many of you have heard this term before? How many of you worry about it? Okay. The term was invented at NASA Ames. And it was the folks who decided to stand up DEC minis because they didn't like the level of service they were getting from the mainframe team. That was the original shadow IT group. And we see this oscillation all the time. I was talking to Donnie Burkholtz at RedMonk about, the pivot from shadow IT back to central IT. And usually innovation goes out to the edges, and then when they get tired of actually running it for themselves, they hand it back to central IT and say, here, run this for me. And it becomes gradually standardized. We say, okay, well, you can have a time series database because we get that it's important now, but you can't have all of them. We're going to give you 2. So, the budget has been flat through this entire era as a percentage of annual revenue. And our ability to deliver software has been improving steadily, but is linear, essentially. And the expectations of the business are not linear. Because it used to be we only wrote software for one part of the business, and now we write software for every part of the business. And every part of the business allows their expectations of IT to grow a little bit every year. But we have more and more people demanding more and more at a faster pace. They're like, well, we only need you to deliver twice as many features in half as much time for twice as many people with twice the scale. And then we have IoT, which I know has been mentioned briefly a couple of times, but we're going from, hundreds of users to millions of users to now millions of apps on billions of devices for everyone, which our budget is still flat. I don't know, how many of you got like a new budget yesterday? No? So we know this is why we have to automate. This is all context. I'm sort of giving you some historical context. Mobile by itself would be a #1 reason we have to automate because, again, expectations are client server, the hardware is only getting refreshed every 3 to 5 years. Mobile, they're throwing the device out every year. So just keeping up with the hardware has become harder and harder. All right, now I really want to scare you. I spend a lot of time talking to folks, and inside GE as well, about legacy applications. What are we going to do about all the apps we already have? How many of those can we convert to be cloud native? What do we do about the other ones? Is it worth an investment in modernizing them? Do we want to make them mobile ready or put APIs on them, or do we scrap them and rewrite them? This is an important problem, and it feels like the important problem, but it is not. By the end of the decade, 90% of the apps that you will be managing are ones you have not yet started writing. This pace of innovation is not going to slow down. We're going to write twice as many apps every quarter as we wrote the last quarter, and if you just plot that line out, most of the problem we are going to deal with is the problem we haven't yet started creating. So I encourage you, as much as, yes, legacy applications and maintenance coding is important, getting your DevOps tools and processes and culture right is the most important activity. And take that message back to your managers. Just to put a not too fine point on it, this is companies that have left the S&P 500 in the last decade and companies that have entered in the last decade. We churned 40% of the S&P 500. We are on track to churn 75% by 2027. These are companies that were the biggest companies in the world and simply are not anymore. Now, they're either all the way out of business or they have just become second string or third string to a company that didn't even exist. The average lifespan of a company in the S&P 500 is down to 18 years from 90 years. So there's a lot of this feeling, especially very large companies like GE, that this could never happen to us. It's already happening to you. Okay, now you're scared, hopefully. All right, we talked a little bit about this kind of global mobile social thing. Let's talk even more specifically. When I started writing software, it lived on a single computer. And for most of my career, that is how software ran. Maybe you had 3. You had a database server, you had an app server, you had a web server. Maybe. It is impossible for me to think of a meaningful business application that for its lifetime will run on a single server. And it seems irresponsible to ever architect an application with that expectation. This is why microservices or SOA or whatever you want to call it has become the only sensible way to think about building apps. Also, we don't get to think about scheduled downtime. Whether it's because our offices are all the way around the world and so we're delivering business applications that need to be available for everyone in the enterprise, or whether it's because our customers are all the way around the world and their expectations of reasonable performance have become totally unreasonable. You guys saw that Facebook was down last night? And Instagram, and there were 5. And 4 of them were down because they depended on Facebook being up. Which I thought was an interesting side effect. The more we decompose our apps into microservices, and over time, the more those services depend on other services that we're not keeping track of, regardless of what build tools we use or CMDB systems we have, clever developers will find a way to subvert the documentation. Those services become mission critical without you even realizing it. So, and the other thing is, it used to be that a lot of questions could be solved with one technology. And I'm not picking on Oracle specifically, although I do like to do that. It used to be, oh, I need a database. Okay, we'll use Oracle. Here, we'll get you an account. We'll create you a database. We'll assign you 6 DBAs. You can learn how to slaughter chickens and burn incense. There are some DBAs in here. Only DBAs think that's funny. You know, teams are bigger. Coordination across a big team is much harder. It used to be 5 smart guys in a room could build OpenStack. Now there's 17,000 people working on it. And these applications increasingly are stretching across lines of business. So it's not that you get to build an app that's for the marketing team, or you get to build an app that's for GE Capital. But they're saying, well, what we really want is, you know, a sort of portfolio management thing for these internal stakeholders to see how this business unit is serving the needs of that business unit. Okay, well, you're tying a lot of disparate systems together. That's not simple. We've talked a lot about all these different tools. I just wanted to give a diagram. I'm going to come back to this diagram a couple of times. But this is how I think of the simplest view of the world of a modern app, right? And there are lots of these different layers. You got a router on top, something where an incoming connection comes in. In the Cloud Foundry world, we assume this is HTTP, unless proven otherwise. You've got some running process that's actually your app. And it should be scaled horizontally, lots of different containers or VMs or whatever. It's running in a file system. That file system represents the language and framework. So if it's a Java app, that's your Java 6 environment plus your Spring framework. Or it's your JBoss JVM. Or it's your Python framework with all of your dependencies pip installed. Whatever it is, there's some composed framework that's sitting on top of some, hopefully, standard base operating system. I'm going to start yelling about Docker in a minute, but not yet. That has to be on top of something that provides compute, something that provides access to network, and something that provides a storage backend. The storage backend, particularly for data services. We have lots of different automation tools. We're going to apply them to different parts of this stack in different ways. And when you think about it, the underneath of that compute, networking, and storage is not standard. And I have organizations that tell me, oh yeah, we're all in on this layer. No, you're not. If we actually went and audited your infrastructure, you have some servers somewhere that have bespoke operating system that's some hand-tooled custom Gentoo script written in Lua, or you know, in theory you have a standardized OS, but in practice it's a run book with a sysadmin who sits down and apt-get installs things, manually assigns IP addresses, sets up IP tables by hand. If people touch a keyboard, that's what I would consider legacy in terms of infrastructure. Progressive is what we see with infrastructure as a service, with cloud deployments. Whether it's, you know, vSphere in some cases we're starting to think of as an IaaS now that it has enough API support. OpenStack, CloudStack, Amazon, I don't really care. Cloud Foundry specifically doesn't care. And then we see the sort of IaaS++ approach with, you know, CloudFormation on the Amazon side and Heat on the Cloud Foundry side. I've got a template that says here's a collection of VMs I want. Somebody described OpenStack Ironic the other day as having replaced all the only good things about bare metal with all of the bad things of VMs. So there's danger in that layer. Third platform is what we really refer to as platform as a service. And I'm going to come back to this idea that this is a totally different way of thinking about infrastructure. But first, I want to support that. I'm actually not a credible person, so now I'm just going to quote other people. Patrick Dubois was the inventor of the term DevOps, started the DevOps days. So if any of you are doing DevOps and Agile, you probably have heard of him. This was his tweet last week. Configuration management as we know it will be like C coding, only required in some specific optimization cases. That's a somewhat heretical statement to make to a room of folks who just spent an entire day talking about configuration management. And I don't think he means that we stop using automation. I don't think Patrick's view of the world is that we go back to having just a few very large servers. And in fact, I'm just going to drill on this point one more time. I said this the other day. I see people do this ostrich thing all the time, where they're like, oh, we're going through this brief window where everything is changing. What I need to do is sort of get my grip, get my arms around these new technologies, learn a few things, make a strategy, and then move forward. Which sounds right. And it feels like it's common sense, except the underlying assumption is that things are going to go back to normal in the future, that tomorrow is not going to introduce twice as many changes as today did. There is no evidence to suggest that will ever happen. This is not like we are going through this weird brief period where IT is changing really fast. This is a permanent state of affairs. I have watched OpenStack itself go from a brand new 17-day-old hipster thing to being boring, in a sense that folks are like, yeah, we deployed that 3 years ago. It's been in production for 2 years. We're thinking of decommissioning it now because we've got other newer ideas. In 5 years. This rate of change is never going to slow down. There is no such future. And so this idea of, well, we've got to learn first and then do is not a luxury that we have. So the idea of, hey, start with tools and practices and then build culture around doing it, yeah, that's the only hope any organization has, is to learn by doing. There is a similar, I think, maybe parallel experience in kind of the nuclear age, which is where this quote came from. When things are radically different, it's usually easier to tell that there was a quantum change after the fact than it is during the fact to go, oh yeah, this is totally different than it used to be, and there's no way what we're doing today is going to help. So I'm going to talk, and I don't want to get super mathy. I actually don't even have enough time to get super mathy. How many of you have heard of the Byzantine generals problem? Okay, 10%. That's actually pretty good. The problem goes like this. A couple of generals are outside Byzantium and they want to sack and conquer the city. Right? The defenses are so strong that unless they attack at the same time, they will fail. If either of them attack solo, the attack will fail. So how do they coordinate themselves? They say, oh, it's really easy. One of us will send a messenger to the other one saying, this is the time we're going to attack. Like, okay, but what happens if the messenger dies on his way there? We don't know. So, okay, well, you'll send a messenger back to tell me that you got the message. Okay, but what if that guy dies? Then you think we're synchronized, and I think we're not. Okay, well, I'll send a messenger to your messenger. Or I'll send two messengers on opposite. So it's an intractable problem, actually. It's one of the original computer science problems. The more generals you have, it's called coordination in a distributed system. The only thing we have that's close to a solution is called Paxos. Well, that's the formal proof. There's a few different technologies that we use to solve this. And essentially it says, we can produce a known level of certainty, 4 nines, 5 nines, 6 nines, whatever, that we're going to coordinate ourselves based on sending just a ton of messages and getting back a ton of replies and doing them in a particular order and counting the order of messages that we receive over time. It's called a 3-phase commit. Why am I talking about this? Right? This is a bunch of math. Because every important change in system software in the last 10 years, this stretch of history we're talking about, has been built around Paxos. The reason everyone thinks Hadoop is so awesome, which it is, relatively speaking, is because Hadoop was built around Zookeeper. Zookeeper is an implementation of Paxos. It's actually Zab, if one of you is a mathematician. I'm cheating a little bit. But which allows Hadoop to maintain consistent state across a large number of servers. Now there's another implementation of Paxos called etcd. Came out of the Docker community. It's what Cloud Foundry uses inside Bosch. If you look at, and you can go through every one of these new cool distributed storage backends. InfluxDB is a great one. You look at what HashiCorp is doing with Consul and Surf. Those are other Raft implementations. There is nothing interesting going on in systems orchestration that does not have Paxos at the heart of it. Because when you start thinking about an app that spans multiple servers, you don't have a scripting problem. You have a distributed systems problem. You cannot solve a distributed systems problem using scripting. I was trying to think of a great metaphor for this, because I really like metaphors. It helps people sort of get their heads around it. I couldn't come up with one. It's actually just an annoying problem. So Bosch was written as a clone of a system at Google, which is the story of most cool things. Hadoop was written as a clone of a system at Google. Bosch was written as a clone of a system at Google by some folks at VMware at the time. And it's been worked on for 5 years. And we didn't really talk about it much for most of those years because we thought of it as just part of Cloud Foundry. But increasingly, I see folks trying to take Bosch out of Cloud Foundry and say, well, we're going to deploy Cloud Foundry using Chef. Or we're going to deploy Cloud Foundry using Juju. Or we're going to deploy Cloud Foundry by hand. Or bake it into our product somehow. And I'm like, OK, that's fine. How are you going to upgrade Cloud Foundry? This is what's called the day 2 problem. Bosch does not run a series of commands. Actually, oh, here's a decent metaphor. How many of you, you know in the newspaper, the Sunday newspaper, they have that like spot the differences thing, right? Where there's 2 pictures of the same scene, but a few little things are different. How many of you get 100% on that every time? OK, good. How many of you diff files by hand? As opposed to using, let's say, diff. Or git diff. A couple of you? I don't understand why, but maybe you have very strange career tracks. Oh, Excel, right. Sorry. We're not good at it. Humans are very, very poor at detail-oriented repeated tasks. Demonstrably horrible at it. Look at what we do with politics. So, if we're not good at diffing files by hand, and we want to get a system from one state to another state. Let's call it an upgrade, or a scale out, or a scale down, or repair a configuration mistake we made initially. What makes us think we're qualified to write a script that does that? And this is why we do so much testing, right? We need an exact clone of production so that we can go and write a script and run it and see what we missed and add those and run that. Well, that's actually manual diffing through process of trial and error. It's something software is good at. So the number one thing Bosch does inside, as do most sort of distributed systems orchestration systems now. I said systems 3 times, and that was not good. It has a notion of the desired state of the world. It has a notion of the actual state of the world. It diffs those, and it generates its own script. It says, oh, you want a cluster that has 2 of this kind of job, and 3 of that kind of job, and 7 of this kind of job, talking to each other on these connections with these ports open. What you have right now is 1 of these, and 4 of those, and 6 of those. So I need to add 1 of these, to kill 1 of those. But before I do that, I need to run the drain script, and I need to adjust the load balancer, and I need to float that IP over here, and I need to attach that storage to this, and move it, resize it here. It generates that manifest, and then it executes it. So essentially, the output of Bosch, if you like to think of it, is something that looks exactly like a CM script. But that's not what you put into it, because we're not qualified. Certainly not at a complex distributed systems level. The other thing it does, and I think this is where I'm gonna throw some crazy ideas at you at the end, but having the same system that executes these commands also be the system that monitors and remediates is really an important concept. So if you say, oh, the HA, to make sure that the process is running, is part of the system that's going to launch the process. Because it means in real time, if the process flaps, if I'm starting an upgrade and I bring the new binary in and I launch it, it's InfluxDB, and I run the binary and it immediately crashes, that upgrade's not working. let's stop. Let's not do that to the other 10 copies of InfluxDB. Let's stop and roll back. Bosh does that. Transactional rollback. So it's called canary. You try the first one. If it doesn't work, stop what you're doing. So you canary, and then you do max in flight, which says if we have 1,000 servers, how many of those do we want to upgrade at once? Probably not all of them, but probably not one at a time either, because that's going to take 3 months, and we're going to have to do another upgrade while it's still running. So maybe 10, maybe 100, you set that, right? These are really, really key distributed systems problems. And it's IaaS agnostic. And this one, I mean, this is a business concern as opposed to a technology concern. But if you decide that the solution to your cloud problems is to write to the AWS API, congratulations, you've replaced Larry Ellison with Jeff Bezos, and you have the same relationship. Some of you are executives. Okay, Bosh does a whole bunch of things. At its heart, it does do configuration management in the sense that it executes scripts, do packaging. It's extremely religious. Bosh is not the solution for all problems. Because in order to do all of this, do HA, do upgrades, do scale out, do all sorts of bizarre day 2 orchestration, it owns everything. Literally, it does the entire build process, makes the packages, runs the agents, owns the operating system. Owning the operating system is a really powerful concept when you're running a large-scale distributed system, because you want to talk about dependencies and tracking your dependent libraries. There is nothing that is a bigger dependency than the OS you're running in. So it's not a perfect fit for every problem. But if there is a problem you can solve with Bosh, it is probably a better solution than what else is available because of that. I don't want to go through every one of these bullet points. I'll run out of time, and I will bore myself. So I mentioned the operating system is part of that deployment. IaaS-specific details are not, which means you can run Bosh on top of Amazon, on top of OpenStack, on top of vSphere, on top of Google Compute Engine, on top of Azure. There are now folks working on running Bosh on bare metal. Bosh doesn't care. Take the same packages, you make no changes to them, and run them elsewhere. That's a really important abstraction. And folks say, hey, what's the benefit of having another layer of abstraction? Why would I want another, why would I use containers instead of just using VMs? Why would I use VMs instead of just using bare metal? The reason is because when you get benefit out of that abstraction, it's worth paying the tax. And Bosh is another system you have to run that is an important critical system. Just like if you run Jenkins and you fall in love with Jenkins, Jenkins is now the most important system you're running in dev. In that if it's down, everything stops, right? The nice thing about Bosh, this is one of those distributed system orchestration concepts. If Bosh dies, none of your services died. It's not in the code path. It's not in the data plane. And from a networking standpoint, it's the control plane, not the data plane. So your VMs are still running, the storage is still attached, they're still answering queries, all your data services are still running. But your monitoring isn't going on. So if something does die of natural causes, it's not going to be resurrected until you fix Bosh. So it's not a system you want to leave dead, but it's not a system that takes other things down. So I mentioned that it was IaaS agnostic. Cloud Foundry now, from a broad level, is language agnostic. And I know we've got folks demoing Go code and Node.js. I know there's a lot of Java. I would love to believe that at some point in the future we are going to have fewer languages and we're all just going to standardize on one. And I worked with a guy who worked on Java back when it was Oak. And he's like, it was going to be the one language to bind them all, but it's not. And if you look at GitHub stats, language proliferation is increasing. We have more and more people using a broader array of languages every year than ever before. And it's going to continue to get worse. So I kind of hate that philosophically, but it's a reality. We got to live with it, which means having a standardized way of orchestrating and managing the deployment of your applications across a whole bunch of languages is really helpful. I don't want to belay that point. Blah, 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 blah. This looks like marketing. I'm not going to read any of this. These are all things that I just talked about that we do. And I'm about to go on a cultural tangent here. A bunch of you said you would do DevOps, right? How many of you believe that your line of business does DevOps somewhere, whether you're on that team or not? Can't really see. Okay, small number, probably reasonable. Come back to that in a second. I did say I was going to rant about Docker. I'm going to rant about Docker very briefly. Containers have been around forever. Containers are a useful primitive. There is nothing magical about them. And if you start thinking about them and orchestrating them the way we think about and orchestrate VMs, they lose their value. In fact, they're just like a not as cool VM because the security is not very good. The reason is, at this IaaS layer and at the BOSH layer, you're really thinking about virtual machines or containers or whatever you're using, but you're thinking about a black box in which some things run. There's a process, you explicitly start it. That's not the unit of value of a platform. The unit of value is a manifest that says, this is the state I want my application in. And keep it in that state no matter what. And by granting that level of abstraction to the platform, you're letting it do all this other stuff for you, right? Figure out what language your app is written in, and make sure the right version of Java is underneath it so Poodle's remediated, and deal with binding to various data services regardless of whether the data services move or not. All that is abstracted for you, but only if you allow the platform to deal with that container as a white box, something it owns. You will never SSH into a container if you're doing it right. That is the usefulness of that abstraction, is to say it's something owned by an automated tool set. If you start treating it like a new version of a VM, why would you do that? Okay, so you guys all said we're sort of doing DevOps. I work with Andrew Clay Schaefer, who was involved with Patrick in sort of starting the DevOps movements. He was the precursor to DevOps days. He was also one of the co-founders of Puppet. So I'm picking on Puppet with kind of his permission. But I've been doing a lot of workshops with big companies, and folks are not doing DevOps the way Google does DevOps. I'm referencing that earlier speaker. We can't do it that way. Sometimes it's because automation is Voldemort and our operations team does not want to be executed. Sometimes it's because we have regulatory constraints that don't allow us to turn developers loose on production. There's this thing in Wall Street called ZDAP, Zero Developer Access to Prod, which is a silly acronym, but it's a reality. And so what we find is people are creating there's devs that don't touch operations. There's DevOps who work with the developers as part of the dev team, but they own the relationship with operations. There's ops or platform ops or app ops, which maybe they're building shared services or shared tools or shared libraries. Maybe they operate the cloud. And then there's like data center operations, folks that actually touch physical things. The reason I harp on this a little bit is if you subscribe to this new bring your own container philosophy, you say, well, we're going to do this with Docker. Docker's awesome. People just bring us our containers, and then we're the platform that runs them. From a security standpoint, that's the worst idea I've ever heard. I don't want to talk about it. But there's a video of me yelling about it recently. I refer to Docker as having unprotected sex with the internet, et cetera, et cetera. But from a management standpoint, let's look at what happens when you need to remediate a vulnerability. Okay, so let's take some typical vulnerabilities. How many of you dealt with Heartbleed? Okay, so Heartbleed hits the OS. You got to patch the OS. You kind of want your ops teams to be able to go patch the operating system for every application in the building without involving every single app dev team. In fact, it'd be really nice if that was possible. That is possible if you're using orchestration to assemble your container image, which is what Cloud Foundry does internally, right? It's not a bring your own container. It's here's your app code mixed with a build pack, which is that file system, the language and framework, layered on top of a generic OS. OS is managed by ops. The build pack is managed by DevOps, and often I see this as being a shared services team. They say, hey, we're going to support Node in our organization. We're going to support Node, and we're going to use our specific monitoring tools. We're going to bake those into the Node build pack. You're going to all use it. The reason we like the build pack to be separate, how many of you dealt with Poodle? Okay, so Poodle doesn't necessarily need to be fixed at the OS level, but it does hit Java 6. So if you've got Java applications, those need to be restaged. And it's really nice to say, hey, guess what? The guys who own the Java build pack, go patch it for Poodle, upload a new build pack, restage all the apps that use it. You don't have to go pull those app developers in, because you remember we talk about, hey, you're waking up the app devs at 2 a.m. every time you can't figure something out in prod, and 6 months into that they quit, because developers like their sleep. We are fundamentally lazy people. And now, not only do you not have a dev team, but you have no institutional knowledge about how that app worked. So it's a real risk in this transition to DevOps of saying, well, DevOps does not mean the developers are carrying a pager forever. It means they're carrying a pager during the period of time that it takes to prove that their application does what it's supposed to. Most large organizations hand it off after that to SRE. And I've started using the term SRE. I stole it from Google, Site Reliability Engineering, instead of DevOps, because DevOps gets confusing. It's worth looking up. There's some great talks. I'm not going to belabor them on the SRE topic. I'm losing my monitors. I'm not actually done. Okay. Here's one other point. We're talking about Rise of the Bots. Somebody had to bring Skynet into it, right? When you have a system that contains a state machine, deals with distributed systems intelligence, and monitors itself to respond to change, you have what's called a narrow AI. So the future of systems orchestration is not scripting. It is not a linear approach. It is an AI-driven approach. By this definition, Bosch is a narrow AI. It's not the only one in the market. The company I started to commercialize Piston, we wrote one called Moxie, which is now available as Cloud OS. It's, rather than targeting orchestration above the VM, it's orchestration of the bare metal to provide VMs. Same problem, one layer down. Same approach. State machine, dependency graph, orchestrated actions. To the best of my knowledge, there is no way to evolve a script-based architecture into an AI-based architecture. I think you could spend a lot of time trying. And I think this is true. If this wasn't true, probably we would have been killed off by the androids by now. I have just a little time left. I wanted to use as an example talking about data services and using Bosch for this, and people say, this is the nice part, this is the calm down part. None of these tools are ever going to go away. How many of you still have an AS400? Everyone? Maybe two? Everyone's got to have two, right? They don't go away. Institutional Oracle is not going away. You will be slaughtering chickens and burning incense forever. But it's operated at an institutional level. It has dedicated resources, and it's provided to everybody. And an upgrade of that is an institutional event. So if you think about what services should I run on dedicated machines versus what services should I run in VMs versus what services should I let the platform orchestrate for me, this is about communication. It's not really about the technology. It's communication and scale. So who needs to talk to whom around upgrades and changes to that service? So if you have multiple business units sharing a data service, it probably should be orchestrated at the IaaS level, because not every one of those BUs is going to be using the PaaS. You're going to have a bunch of applications talking to that data service that the PaaS doesn't know about and can't force a conversation. But if you have a single BU that's all in on platform, and they're writing a whole bunch of apps, and they have a shared data service, put it in the PaaS. You get better orchestration, it's simpler to manage, you get built-in APM and monitoring, et cetera, right? This approach, not these specific tools, but this approach of thinking about your technologies in relationship to the organizations that use them and own them and force the right conversations is really important. So I give you kind of this closing view of what your automation future will look like. You're going to have Chef. You're going to have lots of OpenStack, and maybe you have Foreman or Maz or Crowbar or Piston or whatever, and you've got Cloud Foundry, and you're still using Jenkins and Gradle and Worker. Everything in cloud competes with everything else in cloud by at least 40%. So you just have to get used to that it's an endlessly confusing ecosystem. But use those business conversations to decide which tool is appropriate for which task. Now, I told you we were going to lock the doors and everyone's going to sign up for the mailing list. That's what we're going to do now. I wasn't kidding. This is where you open up your laptops. I'm done, Bernie.
Ready. All right, thank you. Nice job. We got some time for questions, definitely. Questions for Josh? I see people pointing but no hands. We want to go home that bad? No. Okay. We do have a question.
There's a point over there.
Okay, we got one.
Okay, as a professional paranoid, I too worry about Skynet. So if your scripting language is Turing complete, how do you stop Skynet from coming to existence?
Leave a trouble ticket-based workflow in it. That'll slow it down.
What's the SLA on that one? I don't know. Okay, any more questions for Josh?
It's 4 o'clock. Nobody has
It's
questions
4
at 4 o'clock. They all just
All right,
need
we're
a
good.
bourbon.
Okay, thank you. Oh, wait, hold your applause. We got one
I
more.
almost got off the hook.
Do you have a Twitter handle? How do we get in contact with you, or just the boss mailing list?
Oh, sorry. I will post this on SlideShare. Yeah, actually, my Twitter handle was the first slide. I don't know if I can get all the way back to the first slide on this thing. It's actually, that's really the most important action is to follow me on Twitter, not signing up for the Bosch mailing list, because then I will nag you to sign up for the Bosch mailing list every day. It's like opting in, right? Except, oh, there it is. More personal.
Good. Any more
I
hands?
will post the slides.
Oh yeah, we'll have all the
okay.
slides, we'll have the videos online. So we've been recording this whole thing, so we're going to distribute the videos, we're going to distribute the slides. Hopefully by the end of the week, we'll have everything edited and up. So thank you again, Josh.
Cheers.